So let's take a look at another way that these problems could look. I have x squared plus x minus 2 divided by x squared plus 2x minus 3. The instructions are the same. Simplify, identify any x values for which the expression is undefined. So let's first tackle simplify. So again, simplify means we're reducing down or dividing out any common factors. So in order to do that, we first need to factor. Remember when Mrs. Walker and Mr. Brasser said, hey, factoring is not going to go away. You're always going to have to factor. And we were not lying. So let's do our favorite thing of factoring. We have x squared plus x minus 2. That is going to factor into x plus 2 and x minus 1. The denominator, x squared plus 2x minus 3, is going to factor into x plus 3 and x minus 1. And I know that these are the factored forms because if I were to distribute all my pieces out in my numerator, it would get me x squared plus x minus 2. And if I did the same thing in the denominator, it would get me x squared plus 2x minus 3. So I have factored form here. Now that we're in factored form, we need to divide out any common factors. So let's look at these quantities. I have this quantity or set of parentheses with x plus 2 inside of it. There's no x plus 2 in the denominator, so that can't be simplified out. I have this quantity of x minus 1. I have that exact same quantity being multiplied in the denominator. So these x minus 1s divide out, and that's going to leave us with x plus 2 over x plus 3. Now, let's look back. Do we have any common factors? Remember, a factor is something that is being multiplied. We don't have any more multiplication happening in our fraction. We have addition, x plus 2 and x plus 3. So because of that, we have no more common factors, no more common things being multiplied. This is as simple as it gets. We are not allowed to cross out those x's because they are being added, not multiplied. So when the instructions say to simplify, this one takes a little bit more work, but that would be your final answer for simplification. The second part of the instructions say to identify any values for which x is undefined. Remember, that means we're taking this original denominator and solving for values of x that would make it 0. Now, we've already actually done a lot of the legwork for this because we factored our denominator already. So if we take this factored form of our denominator and we set it equal to 0, and we solve for x, we can use that zero product property, which you probably didn't remember the name of, but that's okay. That says if you have two pieces being multiplied together, you can break those pieces apart and set them both equal to 0 and solve for x. So x plus 3 set equal to 0 when solving for x would give us negative 3. X minus 1 set equal to 0, solve for x would give us x equals 1. What this tells us is that this denominator will become 0 if x is a value of negative 3 or if x is a value of positive 1. Well, that's not good. We can't have the denominator be 0. So we're going to say, well, x cannot equal negative 3 and x cannot equal 1 because those are the values of which would make this fraction undefined. And that's what we need to limit ourselves. So what this is doing by saying x can't equal negative 3 and x is not allowed to be 1 is it's just saying that we can plug any number in for x into these equations except for negative 3 and except for positive 1. Now some of you might be feeling a little skeptical because you're like, well, Mrs. Walker, in the simplified version of it, x can be 1 and it's fine. But in the original one, it can't, and that's what's important. We have to look at where we're starting and what we're beginning with, and that's what we have to figure out what x can't equal to. And you might be thinking, well, how does this even look when we graph this? Like, what do you mean it can't equal those values? So let me just quickly show you, because we are going to spend more on that topic as to why x can't be these values and what does it do to it graphically. That's another lesson. But I want to just show you, when we look at the table, what ends up happening. Right? So if you look at it, when x is 1, we get an error. And what I did is I typed this original fraction into the calculator. And when x is negative 3, we get an error. And that's because it's trying to tell the calculator to divide by 0, which is not possible. Okay, so now we have another problem, exact same set of instructions, and you're like, wow, this is getting repetitive. Yeah, because these problems can be really difficult and tricky because they're all going to be a little bit different, even though the underlying concept is the same. So the more you practice these, the much easier it is going to get for you. So let's take a look at example 3. Again, we want to simplify and identify any values for which the expression is undefined. Well, I don't like the way this problem looks in the beginning because it's not in standard form in the numerator. So I'm going to reorder this real quick. And okay. So I'm going to make this negative x squared plus 4x. And then x squared minus 2x minus 8. Let's do some factoring. Now, the numerator is technically not a full quadratic to where we can factor it in like our normal factored form, but we can use our knowledge of greatest common factor and divide out that from the numerator. So what do the negative x squared and 4x have in common? Well, they have a negative x, leaving me with x plus, not plus 4. It would leave me with x minus 4 when I factor that out. In the denominator, x squared minus 2x minus 8, what multiplies to negative 8 but adds to negative 2 would be x minus 4 and x plus 2. Notice now that we have a common factor. We have something that is in common that is being multiplied between the numerator and denominator, and it's this x minus 4 piece. I have an x minus 4 being multiplied in both locations, so I can divide that out, and that's going to leave me with negative x over x plus 2. There are no more common factors because there's nothing else that's being multiplied that's common between the numerator and denominator, so this is simplified form. Now let's focus our attention on finding the values for which the expression is undefined. So I'm going to take this factored version, solving that for x, because that's going to tell me the values that x is not allowed to be because it would make the denominator 0, which is bad. I would have this x minus 4 quantity and x plus 2 quantity, and those cannot equal 0. So something I tend to do to remind myself that these are the values that x can't equal is that when I'm setting this up, I say that it can't equal 0 because then that's going to remind me when I write my final answers, these are the restrictions on our function that x can't be. Solving each of these for x, it's going to end up giving me x cannot equal 4 and x cannot equal negative 2. So there's 2 parts to our answer, the simplified version that I've highlighted in purple, and the values for which x is not allowed to equal, which I've highlighted in blue.